Question 1. So a lot of people just really learn how to do these, so they just learn that it's the 24 lots of pens, the 24C plus 37 R's, because the rulers cost 37, and that's what T equals. So you can just learn this, T equals 24C plus 37R. But I'll just quickly run through it if you want to properly understand it. So we know each pen costs 24 cents. So if you bought one pen, it would cost you 24 cents. If you bought 2 pens, it would cost you 48 cents. 10 pens, 240 cents, etc. So what are we doing every time? Well, we're multiplying the number of pens by 24. So if we've got C pens, then the cost is going to be 24 lots of C, which is 24C. So that's the 24C here. Now with regard to the rulers, okay, one ruler would cost us 37 cents, 2 rulers would cost us 74 cents, and so on. So if we've got R rulers, that's going to cost us 37 times R. So the total cost is going to be the 24C plus the 37R. Question 2. So we've got to work out the time taken by the bus to travel from Dubai Airport to Abu Dhabi and give your answer in hours and minutes. Right, okay, well we know we're travelling at 50 kilometers per hour, which is 50 kilometers every 60 minutes. So if we go and divide this by 50, that's 1 kilometer in every 1.2 minutes. And we've got to travel 165 kilometers, so if we multiply this by 165, you can see it's going to take us 198 minutes. Now we've got to give our answer in hours and minutes, so we get 3 hours out of 198 minutes. That's 3 lots of 60, which is 180 minutes. That leaves us 18 minutes left over to get up to our 198, so that's 3 hours and 18 minutes. Question 3. Now for division, you've got to remember that you keep the first fraction the same, change the sign to a multiplication, and flip the second fraction over. So just focusing on the left hand side, that's going to give us 2 over 7 multiplied by 5 over 4. How do we multiply fractions? It's top times top, bottom times bottom. 2 5s are 10, 7 4s are 28. So we've got 10 over 28. Divide a numerator and denominator by 2 and we get 5 over 14 as required. Now for part B, always when you're dealing with fractions, whatever the operation, whether you're timesing, dividing, adding or subtracting, always start off by converting mixed numbers into improper fractions. So 3 1/6 is 19 over 6. And 1 2/3 is 5 over 3. So that's our starting point, just focusing on the left hand side. So we've converted them into top heavy fractions. Now I need to get a common denominator if I'm subtracting. So both of these I could have the common denominator of 6. So I keep my first fraction the same, and my second one I need to double the numerator and the denominator, giving me 10 over 16. 19 take away 6 is 9, so that gives me 9 over 6. Divide top and bottom by 3, I get 3 over 2, which is what I required, that's 1.5. Back at this point, if you'd chosen to get a common denominator of 18, that's absolutely fine. You would have just had to do a bit more simplifying at the end. Question 4. So we're told 2 things about D. Firstly, it is 110 meters from B, so 110 meters from here. Now 110 meters, so we know that 1 centimeter represents 20 meters. So 110 meters in real life is going to be how many centimeters on the map. So just looking at that ratio there, I can see to scale up from 20 to 110 and multiplying by 5.5. So similarly, looking vertically, on the map, 1 centimeter scales up to 5.5 centimeters. So using a compass, I've gone and drawn an arc of 5.5 centimeters here, and I know that D lies somewhere on that blue arc, because those are all the points, 5.5 centimeters, so 110 meters away from B. Now secondly, I know that D is on a bearing of 220 from C. So from C now. Now bearings we always measure clockwise, so that's going to be this angle here, 220, and the easiest way to do that is to get your protractor out and measure this smaller angle, this obtuse angle, 140 degrees with your protractor, because obviously angles about a point add up to 360, 220 and 140 is 360. And we so draw this line in here with the angle of 140 degrees, and we know that D lies somewhere on that line. So it lies both on the blue arc and on the red line, so therefore X marks the spot. That is where D must be. Question 5. Well, this is very straightforward. So the circumference of a circle equals pi times diameter. Cottage pie is delicious, if you like. So it's pi times the diameter. We're told that the diameter is 18. So pi times 18 on your calculator is 56.548 ... So to 3 significant figures, remember that means 3 digits in total, 1, 2, 3. Do I round the 5 up? No, I don't. The next digit is not 5 or above. So our final answer is 56.5. Question 6. So we're told that the we're going to rotate about the point -2, -1. So get X marks the spot here. Get out your tracing paper and make sure it covers up the shape and also your center of rotation. Draw around your shape on the tracing paper, and my tip to you is to do a little arrow on the tracing paper pointing upwards. Now go and put the pencil point on X marks the spot as a pivot and rotate the tracing paper 90 degrees clockwise until that arrow you drew is pointing to the right. So that will move the shape to being here. So then press through firmly through the tracing paper to cause an indentation in the paper. Remove the tracing paper and follow that indentation, and then just double check, just repeat to make sure that you've done it correctly. Question 7. So, I think a little exam technique here, always try and solve this algebraically and let X equal the probability of whatever's the smallest probability. So we're told that the probability that it takes a white counter is 3 times the probability that it takes a blue counter. So go and let X equal the probability that it takes a blue counter. Now, because the probability of a white counter is 3 times this, that's going to be 3 times X. Now we know that the probability of taking a blue counter or a white counter, in other words X plus 3X, is equal to the rest. So it's got to be a whole take away 1/12, which is 11/12. Okay, because we've only got white, blue and red counters in the bag, so the probability of a white, blue or red is a whole. Given the probability of a red is a 12th, the blue and the white together must be 11/12, and a blue and a white is X plus 3X. So we've constructed an equation to solve. 4X equals 11/12. Divide both sides by 4, giving us X being 11/48. Now X is the probability that it takes a blue counter, so that's our final answer. Question 8. So we're told this is the number of phones sold up to 31st of December, and then 14.5% fewer phones were sold over the next 3 months. So we need to work out a percentage multiplier here. So just set up your 3 columns, original, change and final, and always slot 100 into the original. So that's going to ensure that we're dealing in percentages. Now we're going to buy 14.5% fewer. So that's a reduction, so put minus 14.5 into your change column. And then this number here, our final number, is 100, take away 14.5 being 85.5. Now our percentage multiplier is what we have to multiply 100 by to get 85.5, and that's just going to be 85.5 divided by 100, which is 0.855. So we've established our percentage multiplier. So given we started off with 62 million phones, we multiply this by our percentage multiplier to get 53.01 million phones. Now for part B, we've got to work out the percentage decrease going from 13 to 14. Now to work out a percentage decrease or increase is the change divided by the original times 100%. Now the change in the mean number is obviously 1656 take away 1404, which is 252. So that's our change. Divide this by the original amount, our starting amount, which is 1656. Pop this into your calculator, multiply that by 100, we get 15.217 dot dot dot. So correct to one decimal place, that's going to be 15.2%. Now for part C, work out an estimate for the total number of minutes Polina used. So this is a bit like when we have to estimate the mean, but we just don't have to do that division right at the end. So we don't know how many on 3 occasions we don't know exactly how many minutes Polina used. It's somewhere between 0 and 10. So the best we can do, our best estimate, is to take the midpoint, which is 5. Similarly here, we know on 16 occasions she spoke for between 10 and 20 minutes. Don't know how long. The best we can do is to estimate the midpoint, and so on. So this is a column of midpoints. Now we're now going to assume that on 3 occasions she spoke for exactly 5 minutes, 16 occasions she spoke for exactly 15 minutes, and so on. So we cross multiply to get these subtotals here, add up these subtotals, and that gives us an estimate for the total number of minutes of 590. Question 9. So the list of members of A union B, that just means those that are in A or B or both. So all of A, so all the even numbers, 2, 4, 6, 8, 10 and 12, and also any that are in B, so that's going to add on another 7 and 11, as we've already included the 4 and the 8. You can put them in numerical order, but you don't have to. Just make sure you pick up all the numbers. Now, is it true that 20 is a member of A? So is 20 a member of A? Is 20 an even number? Well, be careful. On the face of it, you'd be tempted to say yes, because 20 is an even number. But remember, the only numbers in town, the only numbers that are part of our universe, is this universal set up here. So these are the only numbers that exist for the purposes of this question. So no, 20 is not in the universal set. So 20 therefore can't be a member of A. Now for part C, we've got to just try and gather our thoughts on what's going on here. So I would suggest you set up a little Venn diagram and overlapping A, B and C. Now we're told that A intersection C is nothing. So there is nothing where A overlaps C, so hence those two crosses there. And I'm also told that B intersection C equals 7. So B intersection C would be either of these two here, but we've already concluded this is an X, so the 7 must go here. So from these two statements here, I've gone and established this X, and this 7. So now I'm going to slot in all the other numbers in the universe. So 1 is obviously, 1 is not even or in B, so 1 is a possibility for C. 2 is obviously even. 3 also is not in A or B, so that's a possibility for being in C. 4 is even and also in B, so that's why 4 is there. 5 is a possibility. Okay, 5 is not even or in B. 6 is even, we've already done 7. 8 is both even and in B, whereas 9 is a possibility for being in C, because it's neither even nor in B. It's not 4, 7, 8 or 11. 10's even, 11's in B, 12's even, and that's our whole universe. So basically, list the members of one possible set of C, and we know C has 3 members. So we must include 7, because that's absolutely guaranteed that it's got to be in C, because it's in B intersection C. It's in B or C or both, and it's in both. So C must be one of our answers. 7 must be one of our answers. And then we can choose any 2 out of 1, 3, 5 and 9. and I've just chosen randomly 1 and 3. So my answer is 1, 3 and 7, but as long as you've got any two of these four plus 7, you're going to get the marks. Question 10. So remember, factorising is putting the brackets in. So what's the highest common factor of these two terms? Well, it's 5. So 5 goes outside the bracket. Open the bracket. 5 times what gives us 25m? Well, that's 5m. Get the sign right. That's the plus. 5 times what gives us 30n? That's 6n. Now for part B, expanding, that's getting rid of the brackets, so we do the claw. What's p multiplied by 2p? That's 2p squared. Get the sign right, it's a minus. What's p times 3? That's 3p. Now for part C, let's look at the numerator. When we multiply, we add the powers. 5 add 8 is 13. So we get y to the power of 13 divided by y to the 4. And when we're dividing, we take away the powers. So 13 take away 4 is 9. So y to the power of 9. Now for part D, it's this two sets of claws. So it's x times x, which is x squared, x times minus 3, which is minus 3x, 7 times x, which is plus 7x, 7 times minus 3, which is minus 21. So we've expanded, we've got rid of the brackets. Now simplifying, we've got to gather the like terms. So the like terms are the x's. Minus 3x plus 7x is plus 4x. So our final answer, x squared plus 4x minus 21. Now for part E, factorise fully. So we're going to be taking more than one thing outside the bracket. So let's work our way along. Let's looking at the numbers. The highest common factor of 36 and 27 is 9. The highest common factor of p cubed and p to the power of 5 is p cubed. And the highest common factor of m squared and m is m. So all of that has to come out of the bracket and open the bracket. So 9p cubed m times what gives us 36p cubed m squared? Well, that's 4m. Get the sign right, that's a plus. And then 9mp cubed m times what gives us 27p to the 5m? Well, that's 3p squared. Question 11. I thought this was a clever question actually. Just got to be careful here. Now we've got to work out the area of the trapezium. Now to work out the area of the trapezium, you've got to average the two parallel sides. So this is the length right away along the top plus 13 and then halve it and multiply that by the height between the two parallel lines, which is 4. So our issue is to work out this total length of this top side. Now obviously we know this component here, this element of it is 13 because that completes a rectangle. So our issue is really to find this extra bit here, and you just need to spot that we can do that by this being a right angled triangle and using Pythagoras where we're finding one of the shorter sides. So basically our starting point is to work out this length here, which I've called x, and I've said x squared equals 8.5 squared take away 4 squared, which is 56.25, square root this, and we get the length of x to be 7.5. So this length is 7.5, this length is 13, so the total length of this top side is 20.5. Now to work out the area of the trapezium, it's easy. We average the two parallel sides, so 20.5 plus 13 divided by 2, and multiply this by the height between the two parallel sides, which is 4, and that gives us 67. Question 12. So we've been asked to use the graph to find an estimate for the number of sunflowers with a height greater than 150 centimetres. So here are the heights. So take your height of 150 centimetres, halfway between 140 and 160. Go vertically up, hit the line, go across and take a reading, and we get 33. Now that's the number of sunflowers with a height below 150 centimetres. We want a height of the sunflowers above 150, so we've got to take 80, take away 33, which gives us 47, and the answer scheme allows anything, or either 46 or 47. Now for part B, use the graph to find an estimate for the median. And the median is middle. The middle sunflower is the 40th sunflower, so here is our 40th sunflower. horizontally across, hit the curve, go down, take a reading, and I got 156. The answer scheme allowed anything between 155 and 157 inclusive. Question 13. Now, to find the lowest common multiple, so I could have done the product by prime factors and pop them in a Venn diagram and what have you to work out what it is. But I think when you're just being asked to work out the lowest common multiple, it's easiest just to do the 24 times table, the 30 times table, and wait till you get to the same number. So that's 120. Now for part B, I've got to write down the highest common factor of A and B. Now remember, the highest common factor would be all the factors that are common to both, so would go into the central bit of your Venn diagram, into the intersection. So let's have a think about it. When we're looking at the 2's, we've got a 2 in common. So a 2 would go into the centre, so that's 2 to the power of 1. And the 2 to the power of 4 would stay over in the A part of the Venn diagram. When we move on to the 3's, we've got a 3 squared in common. That goes into the middle, and the rest of the 3's would go into the B. And then we don't have the 5, the 7, and the 17 in common, so they go elsewhere. So what are we left in common with in the middle? It would be 2 on the one occasion, 2 to the power of 1, and 3 squared. So our highest common factor is going to be 2 times 3 times 3, which is 18. Question 14. Well, quite straightforward really. We just need to find out these two missing y values. So we take our x value and substitute it into the function. So first of all, we substitute it in here. So it'll be 1.5 plus 90 divided by 1.5 squared. Which gives me 41.5, and then secondly over here I substitute 3 in for x, so 3 plus 90 over 3 squared, which gives me 13. I've then got to plot these coordinates, 191, 1.2, 63.7 and so on, and I get this sort of reciprocal graph looking like this in red. Now for part C, I'm being asked to use my graph to find an estimate for this. Now we've just got to go and compare and contrast this to the graph that we've already drawn. We've got y equaling 1 lot of x plus 90 over x squared, not a half of it. So just focusing on the left hand side, we want to line this up with the curve we already have, so I'm going to choose to double both sides, giving me x plus 90 over x squared equaling 30. So where does this curve equal 30? I need to go and draw in a line along the x-axis here. Okay, so I'm drawing where it equals 30. I could have extended this line along here, but basically this is where they intersect. So I take a reading here and I get 1.8. So where this curve crosses the line y equals 30. Question 15. So P is inversely proportional to the square of D. Now because it's inversely proportional, it's going to be K divided by something. Had it been P is directly proportional to, or P is proportional to, it would have P equaled K times something. So this is the division one, so it's K divided by the square of D. So this is our provisional formula, where we now need to go on and work out the constant K. Now in order for us to be able to do this, they need to sort of freeze time for a moment and tell us what P is when we know D and vice versa. So we know when P is 25.6, D is 1/8. So substituting P in with 25.6, D with 1/8, we get this. So multiplying both sides by an 1/8 squared, I can see that K is equal to 0.4. So my final new improved formula is no longer P equals K over D squared, but because I know K is 0.4, it's P equals 0.4 over D squared. Question 16. Now for part A, we've got to work out the area of a triangle which is not a right angled triangle. So use the formula that we're given at the front of the paper, half AB sin C, where C is the angle. So what I like to do is to keep these letters the same and relabel my diagram. So I've relabeled in blue here. So uppercase C is my angle, and these two sides are A and B. It doesn't matter which way around, but I've made A 10.5 and B 17.6. So substituting into half AB sin C, I get half times 10.5 times 17.6 times sin 109. Pop that into my calculator, I get 87.36 dot dot dot. So to three significant figures, that's 87.4. Now for part B, I'm trying to work out the side KL. Now I can't use the sine rule because I don't know a pair. There's no occasion where I know the angle and the opposite side. But what I do have is a situation where I have a side, the trapped angle, and a side, which means I need to use the cosine rule. Now for some reason that is beyond me, they go and choose to call the angle a different letter now, so we're now going to be calling the angle A. Remember that the uppercase component is always the angle. So I know it's a bit confusing on the diagram, but I would rather relabel my diagram for a second time to tie in with this lettering. So now my angle is capital letter A, and I've done this in purple. And then my B's and C's are the two sides. Well, B might as well remain as being the 17.6, and now this 10.5 has become my C. And obviously the side is lowercase a is KL, which is what I need to work out. So A squared equals B squared plus C squared minus 2BC cos A. So A squared equals 17.6 squared plus 10.5 squared minus 2 times 17.6 times 10.5 times cos 109. So A squared is this, square root this, and I get A being 23.245 dot dot dot. So to three significant figures, that's 23.2. Question 17. So remember, to differentiate, you multiply by the current power and reduce the power by 1. So 3 2's are 6, and 6x, reduce the power by 1, so squared, 6x squared. Moving on to the second term, multiply by the current power, minus 9 times 2 is minus 18. Reduce the power by 1, so it's no longer x squared, but x to the power of 1, which is x. And then the plus 7 just drops out. So that's our final answer for part A. Now remember, the differential allows you to work out the gradient for any value of x. Now we're actually told what that gradient is. Okay, we're told that the gradient in question is minus 27 over 2. So this differential is giving us 27.2, so it's equal to minus 27 over 2. Now, to undo this division by 2, I've chosen to multiply both sides by 2. I've added 27 to both sides, giving me this quadratic, which I can solve. Well, I've just chosen, as all these terms are divisible by 3, I've just simplified it to 4x squared minus 12x plus 9 equals 0. Now, you can either factorise that, like I've done here, and get the repeated solution of 3 over 2 for x, or you could, of course, have used the quadratic formula. Doesn't matter which. Had you been using the quadratic formula, A would have been 4, B would have been minus 12, and C would have been plus 9. But either way, you're going to get your x value being 3 over 2, which is 1.5. Now, to work out the y value, I've got to substitute this x value back into the curve. Be ever so careful not to substitute it back into the differential. It's a common mistake. So substitute it back into the original curve. So it's 2 lots of 1.5 cubed minus 9 lots of 1.5 squared plus 7, which gives us minus 13 over 2, which is minus 6.5. Question 18. So I think to help us gather our thoughts with these, it's just nice to do a little sketch to start with. So to go from A to C, we've got to go sort of 3 along and 8 down. So that's sort of A to C. Ignore the arrowhead for now. That's A to C. And to go from D to C, we're sort of going 5 along and 6 up. So there's a little quick sketch. A to C would be going down that one, D to C would be going up that one. Now we've got to find D to A as a column vector. So we've got to get from D to A. So to do that, we're going to go from D to C and then C to A. Now D to C we know, that's 5, 6. Now C to A is the opposite of A to C. So it's the same as this vector here, but with the signs reversed. So -3 and +8. We then add these two vectors together, giving us +2 + 14. Now we're told that the position vector of D is 2, 5. Now a position vector describes how you get to D from the origin. So to get from the origin to D, we would go 2 along and 5 up. So let's just pop in the origin to help us gather our thoughts there in the diagram. And we're told that E is such that DE is 2 lots of AC. Now A to C was going down this one at that sort of angle. So going from a D, really 2 lots of that vector would take us to E being about here. And we're being asked to find the coordinates of E. Now in order to find the coordinates of E, I really need to start off just by finding the vector from O to E. Now the vector from O to E is going to be O to D plus D to E, but remember D to E is 2 lots of AC, so 2 lots of 3 minus 8. So as a side working, I can work out that DE is 2 lots of 3 minus 8 AC, which is 6 minus 16. So back to what I need to do. I want to go from O to E, so that's O to D and D to E. Well, O to D we know is 2, 5, and D to E we've just worked out as 6 minus 16. Add these together and I get the vector 8 minus 11. Now this is the position vector. This is the vector that takes you from the origin to E, 8 along and 11 down. So my coordinate of E must be 8 minus 11. Question 19. It's very straightforward, I think, for part A. If the chance of the Marys win is 0.32, and then the Mary not winning, Naveed winning, must be the rest to give you a whole. So 1 take away 0.32 is 0.68. Now they play 2 separate games of table tennis, the first game and the second game. The probabilities aren't dependent on each other, so it's just a repeat. So Mary winning's 0.32, Naveed winning's 0.68, as it is with the second game. So 0.32, 0.68, 0.32, 0.68. So we've been asked to complete the probability diagram for part A, which is what I've done there in blue. And then secondly, for part B, work out the probability that Mary wins exactly 1 game of table tennis. So let's think about the journeys down these lines. For Mary to win exactly 1, she either wins then loses. That's winning 1, losing 1. Or she loses, then wins. This is Mary we're talking about. So loses, then wins, or wins, then loses. Each of those 2 journeys means she wins only the once. So how do we end up with this scenario here? She wins and then she loses. So 0.32 times 0.68, which is 0.2176. Or alternatively, she loses and then she wins. 0.68 times 0.32, so another 0.2176. Now we don't mind which of these 2 scenarios happens, win loses or loses wins. Either way, she wins only 1 game, so we don't mind whether it's this one or this one, and when it's or we add them together, so 2 lots of it gives us 0.4352 as the answer for part B. Now for part C, we've got to work out the probability that Mary and Naveed both take a bottle of the same type of drink. So that could be water, water, orange, orange, or cola, cola. So if Mary takes a water, that's 3 out of 10. And then Naveed comes along to take one. Well, there's only 2 waters left, and there's only 9 bottles left, so hers would then be 2 out of 9. So the chances of water, water is 3 over 10 times 2 over 9, which is 6 over 90. Alternatively, orange, orange. When Mary taking an orange to start with would be 5 out of 10. Then Naveed coming along and then taking an orange would be 4 out of a revised total of 9. 5 4s are 20, 10 9s are 90. so 20 over 90. And the third scenario is cola, so 2 out of 10 for Mary, then 1 out of 9 for Naveed, giving us top, bottom, 2 over 90th. So we don't care whether it's water, orange juice, or cola. We add the 3 together, and that's 28 over 90. You could simplify it if you wanted to, but you didn't need to. Question 20. So for part A, I think the first thing to do is to sort out the minors power. So just flip it over to undo the minors. So we've got 27f cubed over 125e to the power of 12. And that's got rid of the minors. Now we can now attach the 2/3 power to each part. So the 27 in the f cubed and the 125 in the e to the 12. Now the 27 to the 2/3 and the 125 to the 2/3, at the end of the day you could just pop those into your calculator to get the 9 and the 25. Or you can appreciate that this means you cube root and then square. Cube root of 27 is 3, 3 threes are 9. Or the cube root and square, cube root of 125 is 5, 5 squared is 25. So that sorts out the 9 and the 25. Now here you've got to remember that where you've got one of these, where you've got something to a power in a bracket and that bracket to a power, these two powers can just be multiplied together. So 3 lots of 2/3 is 2, so f squared, and 12 lots of 2/3 is 8, so e to the power of 8. Now part B is tricky, this is A-level really. But anyway, let's give it a go. So I think the simplest way to do this is try and turn everything into being 2 to the power of something. So you replace the 8 with being 2 to the power of 3, and you replace the 4 with being 2 to the power of 2. So then on our left-hand side, we can say to ourselves, when we multiply, we add the powers. So this is going to be 2 to the power of a half plus n over 3. Or a third n, and on the left hand side when we divide we take away the powers, okay, so we've got 3x take away 2n, so we're left with 2 to the power of a half plus n over 3, a third n, equaling 2 to the power of 3x minus 2n. Now because these are both 2 to the powers of something, these powers have got to equal each other, so we can say half plus n over 3 must equal 3x minus 2n. And remember, n over 3 is just a third n. So at that point, I now just need to make x the subject. So I've added 2n to both sides. I've divided by 3, and I get x equaling 7/9 n plus a sixth. Now that's my final answer. That's fine. The answer they gave in the as their first answer in the mark scheme, although they allowed my answer, so that's fine. They basically they've chosen to put them both over a common denominator of 18. So they've multiplied top and bottom here by 2, giving us 14n over 18. Multiplied top and bottom by 3, so 3 over 18. Combine the numerators, you get 14n plus 3 over 18. So if you've got that bit there in the square bracket, lovely. But if you've got my answer up there, that equally would have given you full marks. Question 21. So the first thing to take on board here is to really notice they say total surface area. So it's going to be both the curved surface area of the cone of pi r L, but also the circle at the bottom, which is pi r squared. So that's our total surface area. Now we've got to work out the lower bound of this. So we want the lowest value for r, for the L, which is the slanted slope length, and for r again. So let's sort out our lower bounds. Now for the diameter, it's 6.8 to the nearest 1 decimal place. The lower bound for that's going to be 6.75. So with regard to the radius, our lower bound radius is going to be half of this 6.75, which is 3.375. And then for the slanted height of the cone, the lower bound is going to be 9.15. So that's what I've used in here. So just so we're clear, lower bound of diameter is 6.75, then halve that for the radius. The lower bound for the slanted height is 9.15, just use that directly. So substitute that into your calculator, you get 42.271875 lots of pi, which to three significant figures is 42.3. No, it's not. What am I saying? No, it's 42.271875 pi. That is the final answer. But we're seeing k lots of pi, so k is 42.271875. So k rounded to three sig figs is 42.3. Question 22. Now, I didn't think this was too bad for the hardest question on the paper, and if you sort of practice these, this was fairly straightforward. So take the linear equation, the top one, the one without the squares, and make either x or y the subject. As y is already just a single y, it's easiest just to make y the subject, so take away 2x from both sides, so y equals 3 minus 2x. Now I'm now going to take this value for y, 3 minus 2x, and substitute that in, replacing the y in the non-linear equation. So rather than x squared plus y squared equals 18, it's going to be x squared plus 3 minus 2x all squared equaling 18. Now multiplying out the pair of brackets, you get 9 minus 12x plus 4x. Gathering up our left-hand side, because we've got the two terms with x squareds in it, we get 5x squared minus 12x plus 9 equal 18. Taking away 18 from both sides, we've now got a quadratic equation which we can solve. Now you can either use the formula, where a would be 5, b would be minus 12, and c would be minus 9, or you can factorise it. Either way, you're going to get your two values for x of being minus 0.6 and 3. Now we need to work out the y values as well, so that's easily done by substituting these x values back into either of the equations, but obviously back into the linear one would be easiest. In fact, I've used this version of the linear one, my equation 3. So I've just substitute my two values of x back into y equaling 3 minus 2x to give me y values of minus 3 and 4.2. So when x is 3, y is minus 3. When x is minus 0.6, y is 4.2.